Module 13A, talking about correlation today. I know it says Module 12A down here, but that's because it was it used to be 12A. So for 13A, when we're talking about correlation, one of the big things you need to understand is that it is basically taking data and turning it into a graph, kind of like the ones down here, and then deciding whether that relationship basically is strong or not so strong, and also is it positive or negatively correlated. All right, so we're going to talk about all those things today. We're going to start off with the concept of making the graph. So right here we have some data. If I wanted to turn that into a graph, I would have to just kind of establish what my axes should look like. This goes, the highest number I see over here is 34. And then the highest number I see over here is 590. So I'm going to have to scale this a little bit differently than I might some other things. So I'm going to, let's see, I'll do this by 2s maybe. See if that's going to work. Actually, I'm going to do every 4. So 0, 4, 8, 12, 16, 20, 24, 28, 32. All right, so that 35 is going to be a little bit outside of there, or 34, I mean. Or no, it'll be perfect. It'll be good. And then this one, I could use 0 as a start. This is going to be pretty big, though. We probably just need to go 0 about every 50. So we're going to do 100, 200, 300, 400, 500, and 600. I'll just make it somewhat easy to figure out. Okay, so, and I'm just going to do 1 point at a time. So we have 9 and 260. So 9, and I'll just use a different color here. 260 would be kind of like here-ish. 13 and 320. 13, 320, kind of up in there. 21 and 420 would be right about here. 30 and 530. 31 and 560. 31 and 550. Those points are pretty close. 34 and 590. 25 and 500. 28 and 560. And then 20 and 440. And then 5 and 300. 5, 300. Right there. All right, so you can see what that scatter plot looks like, and you can see that there's basically kind of an overall trend this direction. All right, so we would say that that has a positive correlation because it has a positive slope. And what that means is as one thing increases in value, the other thing also increases in value. Whereas a negative slope would show that as one thing increases in value, the other one decreases in value. And also, notice how all these points are pretty close to that line that I could create. We call it a line of best fit. There's other ways you can call that line, but basically they are very tightly related to a line, and so that's what makes them such a good or strong relationship. All right, so we're going to take that concept and we're going to apply it down here in the next section. So for each of these graphs, we want to give whether it's a positive or negative correlation, and then also whether it's going to be strong or weak. This first one, A, if I were to make a line that kind of goes through the middle of the data, that would be a relatively strong and positive relationship. This next one, if I were to do a line of best fit, it would probably go kind of like that. So that would have a negative correlation, and that's relatively weak. Okay, so I know you can kind of tell how to put a line in there, but that's still relatively weak. This one is positive, and it would be even stronger. I'm going to do an S plus just to show that's even stronger than this other one that we had. This one, that's a negative correlation. That one's close, but that's probably still strong because you can tell a difference. This next one, it does kind of trend upwards like that, so that'd be a positive correlation, but it's definitely in the weak category. And then this last one, I mean, you can hardly tell. Like I could make a line lots of different places and it would be kind of similar. So this would be pretty hard to tell, and it would definitely be weak. Okay, so because we have this concept of like a strong and a weak correlation, there's actually a statistical way to figure that out. So when we do this thing where we make a line of best fit, that's called a regression line also. And regression lines are used to determine how close data are to one another. And more importantly, it can give you a value for how closely related things are. So if we have a really strong correlation, all right, that would be at either +1 or -1. If I got something that was perfectly in line with each other, so they're actually dots that would actually make a line, and none of them would be a little bit off like these ones are, they'd actually be right on the line, every single one of them, that would be either a -1 for a negative slope or a +1 for a positive slope. So anything off of that, anything less than perfectly in line, would start to go this direction towards 0. And a lot of our stronger ones up here, like this one, letter C, is probably, because it's positive, is probably way up here at like a 0.9-ish value, maybe 0.97 or something like that, even for an R value. As we get closer to weak, like this one, that would be closer to 0. So this regression that they tell us up here, that is a very weak R value. That's 0.08. That's way down here. Really, really low. All right, so let's try to do something with that information. So this says down here, it says to match the correlation coefficients to their correct graphs. So this one's positive and relatively close, positive and really close. So I'm going to look at those two first. So this one is probably C, and then the other one is probably A. All right, those are the most like those. This one, we talked about how that had a positive trend to it as well, but it was pretty weak. So that would probably be 0.33. And then we have these ones. That's a negative, that's a negative. This one's probably stronger than this one. And so this is probably letter D out here. And this is letter B. And then the last one, this is the one we could like hardly tell. We could make 5 million different lines of best fit, and none of them are like necessarily the best fit. So that would be a 0, meaning there is literally no way to find any correlation. That's graph F. So I hope that helps you see what you can do on your practice.